These are all our circuit components for our PCB. These are the three different types of regulators, the 5 to 3.3 volt, 5 to 9, and 3.7 to 3.3. This is the USB to get information to the MCU, SD card for information backup, all the op amps for the circuits. This is the MCU, the ESP32S3. This is going to be the batteries for the battery backup. This is the power supply to take AC down to 5 volts. And then this is the voltage transformer.
So these are our CTs. They're also known, their name is current transformers. We decided to go with the Brokowski coil style because they're easy to open and install around an existing wire. So that will facilitate the option of installing our product in a existing panel rather than a new construction. They connect to this integrator, which provides a reading of a max of 0.33 volts through these wires, and we can connect this to our PCB and get a reading based on what the CTs are picking up. So this portion right here is what we're going to use for our voltage reading off of the panel. We decided to go with banana plugs and alligator clips because again, it's easy to install on existing panels, and this is also easy to install in the field as they can just be plugged in. We also have the adapter to connect to our PCB, so everything can be removed fairly easily. So to test our Brokowski coil, we connected our coil to the phase A of this panel. We connected our integrator to a 9-volt battery in order to power it up, and using this phase A output, we measure what it would come out. So we got that measurement with this handheld oscilloscope, and we compare it to a measurement that we got on amperage with this handheld device. Our results are pretty consistent.
Seen here is our voltage measuring circuit that we're using to measure voltage of each line. This is the layout from Fusion 360, and this is our prototype circuit of this voltage circuit. When running the circuit through a simulation, it had a maximum voltage output of 2.9 volts AC and a minimum on the same waveform of 1.13 volts. When testing the circuit with an oscilloscope, it received very similar readings of a maximum V plus of 3.04 volts and a minimum of 1.14 volts. Seen here is the current measuring circuit on Fusion 360. And seen here is the same circuit in a prototype breadboard version. When running the circuit through a circuit simulator with 333 millivolts in, which is going to be the maximum voltage we can receive from the CTs we're using, depending on the rated amperage, the circuit simulation was 2.99 volts maximum on the AC waveform and 1.027 volts minimum on that AC waveform. When testing the prototype circuit with an oscilloscope, it got 2.79 volts in maximum on the AC waveform and a minimum of 1.37, so very, very close to the circuit simulation.